Those two are the same.
Well, those are both a sequence. What's that? Sequence is yours.
Sequins are those really shiny things like girls wear.
Sequins, those are sequins, not sequence. Close enough. Here's what's going on. Shh, guys, come on. This does not take very long to get through this first section, so let's walk through some problems, do some stuff, and go through this. What's happening here is that you have two different types of sequences here. You have one that's called a finite sequence and an infinite sequence. Could you figure out which one is which?
Yeah.
Which one's the finite?
Left one.
First one.
The first one. Why is that? Because it ends. We all know what dot, dot, dot means, right? To be continued.
Unless you're Mamma Mia, and you know it.
What?
Never seen it. Tell me somebody's seen Mamma Mia.
I've seen part of it, but I don't know what you're talking about.
Yeah, a song. Her mom is Italian. She talks about her dates, and at the end of the date, dot, 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 and the girl will say something. That's what it means.
Sorry.
Yeah, what is that? What's that called? Three dots?
Ellipsis.
Ellipses, I think, yeah.
Oh, what?
An asterisk.
Anywho, here's what's happening. Inside of sequence, now that we all know what this is,
Right there? Disappearing.
again, I'm not worried about writing all what everything's going on here. What I want you to see is how they define these things. Obviously, in this sequence, there are how many terms? There's 5 terms. So what they do is this is the first term, second term, third, fourth, fifth, and so on. That's how they write that out.
Like 1x.
Exactly. That's why they call it the domain and the range. Think of the domain as what number is it in the sequence. The range is what is the value of it. So like he was saying, this is kind of like your x values generate some y value. You can think of it as a function. Okay. Yeah, and the pattern that's occurring here is 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, and so on and so forth. So that the sequence can be written out as 3. Yes, sir?
Is this like the n over 2 times n or something? Will we get into that?
Yeah, we get into stuff like that. We will get into stuff like that. So what's happening here is you're getting this, what we call a sub n. And this is what we're using as like a generic write out for a sequence. That value n, this here, is the number in this, what do you want to call it? The nth term. So if we have a sub n equals 3n, and I want to know what is the 4th term in that sequence, what would I do with the 4?
Place.
Exactly. So if I want to figure out that, it would be 3 times 4. So the 4th term in that sequence is
12.
Okay. That's what that means. A sub n. Okay? Okay. So as you go through these things, what we're going to wind up doing is we're going to list out some very simple, what are the first 6 terms in a sequence, things like that. What I was saying with the whole idea of the x and y, if I wanted to list out the first six terms of that, can I just use my calculator for my table? Easy. It's really what it is. You can use your table value to list out your 6 terms, because that way you don't have to worry about adding, subtracting, multiplying, dividing with these things. You should never get these wrong. Unless you got bad thumbs or bad fingers when you're typing. Pressing the wrong buttons. Wow. Again, if I wanted to figure out what the first 6 terms are here, could I just, this is what they're going to ask you. What is a sub 1? What is a sub 2? What is a sub 3? What is a sub 4? What is a sub 5? What is a sub 6? Again, if I'm looking at this in terms of making my life easier, oops. I would hope so. Wouldn't want to do this by hand. Isn't this the same idea? What's x is 1, x is 2, x is 3. Let's go into there and go 2. I mean, obviously, some of these values we don't need to worry about. You should be able to do this on your own. So, first term is 5, second one is 7, third one is 9, fourth one is 11, fifth one is, and so on and so forth. Whatever. Again, there's no reason for you ever to get these problems wrong. Okay. The weird stuff starts to happen when you have to figure out what the patterns are. How do you write it out in terms of the rule? And this is where most students struggle, because you guys like to overthink. You forget to how to work with patterns and how do you set things up. So what I want to do here is look at these. Look at this first one. We'll do these in order. Take a look at what's happening here. You're going negative 1/3, positive 1/9, negative 1/27, positive 1/81.
No, square.
Yeah. What's happening? What's that shape? You're getting there, yeah. What's happening here is most people recognize right away that your signs are alternating. And in order to alternate signs, you have to use multiplication. Negative times a negative is positive, positive times a negative is a negative, and so on and so forth. So you wind up working with the negative values. And I've heard both you guys, a couple of people have already figured out what's happening. You're multiplying it by negative 1/3 each time. Correct, and that's where I'm getting at. What's happening here, when you want to write it out in terms of the rule, a lot of times it takes students a while to start going through, okay, I'm doing this each time. And so on. But how do you write that out in terms of, well, my generic rule is what? So you're saying negative 1/3 n. Now, that means that n is the number in the term in the sequence. So my first term is when n equals 1, n equals 2, n equals 3, n equals 4. And if I'm using this rule, I'm getting negative 1/3 times 1, negative 1/3 times 2. See what I'm saying here? What's happened is that that is not the correct placement for the n. So you have to decide, am I using a fractional value of it? Am I using something else? Or am I using an exponent of it? The n is in the exponent, yeah. So what's happening here is most people tend to struggle sometimes. They'll realize what's happening. Oh, you're multiplying by a negative third. But how do you relay that in terms of some sort of an equation? It's the exponent. Yeah.
The n can either be the like subscript
Yeah.
thing or the exponent, only those two, or is there
No, you can have this subscript here, that a sub n, just means the n value is the number in the sequence. How do I get the third term? Well, to get the third term in the sequence, this has to be cubed.
Right. So, but those are the only two options, it's either subscript and exponent, or it's not.
You can have well, remember the first example we had with 3n, 3 times n? So it could be placed, it could be addition, it could be division, it could be multiplication, it could be an exponent rule, it could be a root rule, half powers, things like that. It's totally possible. And it's not so much a problem, it's a problem, but it's not so much that it just takes a while to, how do you write it out in terms of an equation? And that's where a lot of times students mess around with their calculators to try to figure out what the pattern is working with. Because you guys all have the table function, you should be able to put stuff in the table to make it work. Use your y equals, mess around with it, try to figure out how you get the pattern to work correctly. Does that make sense? All right, well, take a second and let's see if we can figure out what's going on here. This one takes a minute or two to figure out. What do you got?
And it goes plus 4, then plus 6, then plus 8.
Okay, plus 4, plus 6, plus 8, plus 8.
And then plus 10.
Okay, well, how do you write that out in terms of this?
4 plus.
You have to start with n being 1 because it's the first term. 1 plus 2 is 3, so that's not correct.
n times n squared plus 1.
n squared plus n. If it's n squared plus n, I get 1 squared plus 1, which is 2. Okay. If I use the second term, I get 2 squared plus 2. I get 6. 3 squared plus 3. I get 12. 4 squared plus 4 equals
What?
okay.
Yeah, but that's
Okay. That's one way to do it. I didn't think of that one. That works. It's nice.
or wouldn't it?
How do- What's another way you can do this? He gave you a pretty good idea here.
N plus N plus N.
No. That'd be 3n. That's the first one. Close.
2N.
What's the GCF of this?
N times 1.
Isn't that the same thing as what he did? Usually people get that. What's 2? Isn't that 1 times 2? Isn't that 2 times 3? 3 times 4? 4 times 5? And so on and so forth? That's nice, it works. I never thought of that. Again, it takes a while to figure out what the pattern is sometimes. And that's okay, because you guys haven't done that in a long time. You did some of those arithmetic and geometric series sequences before. You did that. Did you do a little bit of that in geometry? Yeah, you did a little bit of it. But you guys did real simple ones, like adding, subtracting. Some of these can get a little bit messy. No, these are gonna make you think.
Yeah, it's simple things that you can. Oh, that's the thing.
And this stuff will force you to have to actually put some trial and error on paper, which is fine, but you should get them. So let's talk about this then in terms of a series. The difference between a sequence and a series is that a sequence is the list of numbers, 3, 6, 9, 12, 15, and so on. A series is going to be 3 plus 6 plus 9 plus 12 plus 15. The series has the addition symbols in it. You're adding up all the values from a sequence. Okay? And this is where we introduce you guys to what's called summation. Sigma notation. It's the Greek letter sigma, means add, summation. So what happens here is, how many terms are in that series? 5 of them. You're starting with the first term and you go through 5 of them. So how you write that out in terms of n's is n equals 1. That's the first term. There are 1, 2, 3, 4, 5 terms in here. And do you remember what the pattern was for this one, for the sequence? 3n. So what that means is you're going to figure out what's the sum of all of that, which basically means you take 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5. Real difficult math today. What's 1 plus 2 plus 3 plus 4 plus 5? 1 plus 2 is 3. 3 plus 15.
I was gonna say 16.
What's 3 times 15? 45. So what's the sum of 1 through 5? 3n. Okay. Or alpha window 2. Oops. Do your calculator. Alpha window 2.
Illegal.
Everybody else can use it except for him. Alpha window number 2 Then you're going to hit, from the variables, instead of being n, just use your x buttons. Start at the first term. You go through the 5 of them, and you fill in your equation. Five. You're filling exactly what this is right here. The only thing that's different, instead of having an n, you're using x's. That's it. What's that? Yeah, it
You
doesn't.
should just add all the numbers together.
Yeah, if you want. That's too much work.
On the test, you're gonna give us that and say add these right numbers.
You want to try? We can do a random problem, and if I can add the numbers, plus X,
That doesn't make sense.
Okay. Now, this is a, yes ma'am.
For the end, like, so, that's where it starts basically. It's not where it starts at.
Yep. Sometimes it'll actually start from the third, what's the sum of the third through the fifth term, or what's the sum of the fifth through the 18th term. Some of those, but it'll be on there. So you start at 1, go through something, or you start at 2 and go through 6. But those are those values. It tells you that. What's that?
So the middle is just all matched up.
Yeah. Now, the difference between a finite and an infinite series is that an infinite series doesn't have an ending point. It doesn't tell you how many terms you have to add together. Well, you can, and we will in section 11.4. There's a formula for that. No. So if this was the number, the total number in my finite series, what's the total number in an infinite series?
45, so it's divided by 5.
Infinity, right. Willis was just joking around and he got the answer right.
No,
Well, I said.
no, how? Infinite series, infinity. It's.
I know. So an infinite series would be the same thing. N through 1 through infinity of 3n.
How do you pull the bottom of the and put that on top of it?
You can't.
The answer is infinity.
How do you add up a bunch of terms that'll be adding to infinity? What happens here is,
Segments.
what happens with this though is if you have like we're talking about infinite geometric series, which we will talk about that, there is a number value that they are going to be approaching. And we will discuss that at 11.4. Is it T? No. And we'll get to that.
So then how do you?
We will, don't worry. Yes, sir.
When our calculator with the E, because do you put 3n there or the 15 or the 45?
3n. It's going to give you the answer of 45. That's why you weren't getting it to work. You have to have a variable in there. So again, as we're going through these types of problems, what's happening is that you can figure out where your starting value is. You're starting with 1, and you're adding up to however many terms are in the sequence, or in the series, excuse me. So what I want you to do is take a couple of minutes, see if you can, I want you to do 2 things. Write it out in terms of the summation notation, but in order to be able to do that with the E, but in order to be able to do that, you have to figure out what the pattern is. You have to figure out what the equation is going to be on, you got to figure out this part here, the equation part. Okay? So take a couple minutes, figure that out for those 2. And you guys were able to figure out in this case here that it's 5 times n. And you're going up through 20. That's how you're going to get that pattern out of this series. When you put that in the calculator, you guys all got
105, that's actually right.
good. Now the other one, it's a little bit trickier. Obviously, it's an infinite series. What's that?
N over plus X.
Very good. There you are. That's it. I know, it's frustrating when they get to be that easy, because you overthink it. And that's what I told you guys, you're going to overthink these. Yeah, go. Oh, we just figured out what this was. The summation, since this is a finite series, we know if you do all the work, you're going to get 1,050 when you add it all up. That's all it was. Again, on this case here, I can't do that because I don't know how.
So you just write that.
Yep, that's all it is. That's it. Okay.
What was,
N over N plus 1. N starts with 1, so it's 1 over 2.
N over N.
N over N plus 1.
Oh, I thought you meant N over N, N.
Oh, no.
That would just be 2.
Yes.
Okay.
Each and every time. What's that gun? A limit button? Yes. What are you going to do here?
Same thing.
Do I have to solve for anything? I just type it in. I should take your calculators away for this.
Oh, you should not.
Is there a special, you're a math.
What's that gun? I can't hear him. Stop talking.
Is there a special formula that I
Yes, you press alpha window.
2.
2.
or scroll down?
Okay? I should make you do these. Long before you guys all had these fancy schmancy calculators, you actually had to do some work.
Only if you want.
I know, only if you wanted to. So what happened here is that there actually are some special patterns of these things that work. I don't care. You don't need to know these because you have a calculator.
Why is I in there?
This is not an imaginary number. They're just saying that's the variable. Don't worry.
Oh.
There's no imaginary
That
numbers.
shaped my
Okay?
mind.
Don't worry. There's no imaginary number. So again,
That's a terrible variable.
I agree. I agree. What would you do with your calculators here?
Type it in.
You type it in. There's no point for us to even worry.
You know, can you make
Oh yeah, you can change stuff around if you want. It's fine.
So are those even?
You'd be using your calculator. I'm not going to ask you to derive some formula or anything like that. Yes, sir. Yeah, there's a bunch of scrap paper back there. Help yourself.
I'm gonna do scratch paper.
This won't take it. The worst part of this is going to be figuring out what the pattern is for some of them, because you guys are going to overthink it. Don't overthink it.
are all of them on?
Yeah. Okay?
Wait, do all of them?
You overthink things, you get mad.